In this video, we'll quickly understand how deep learning has pushed image recognition to a whole new level. We'll look at object detection, real-world applications, the role of GPUs, and how neural networks are structured. And yes, we'll pause for short quizzes so you can check your understanding as we go. Deep learning has become one of the most powerful approaches in artificial intelligence. It is especially useful when the problem is complex and the data is rich, like images, speech, or language. In image recognition, deep learning helps machines learn patterns directly from data instead of depending only on handcrafted rules. Although this article focuses on image recognition, deep learning is not limited to computer vision. It is also widely used in natural language processing, where systems understand text, and in speech recognition, where machines convert spoken words into meaningful output. This broad success is one reason deep learning has become so prominent. Computer vision has seen major progress in recent years, especially in deep learning-based object detection. A big reason is improved computing power. Another important reason is the widespread use of GPUs, or graphic processor units, which can process large amounts of data much faster than traditional setups for these kinds of tasks. Object detection is a specific task within deep learning and computer vision. It does two things at the same time. First, it identifies where an object is present in an image, and second, it tells us what that object is. So unlike simple classification, object detection combines localization and recognition together. Now that we've covered core concepts, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. What has helped accelerate advancements in deep learning-based object detection? The correct answer is improved computing power and GPUs. The article highlights improved computing power and the widespread use of GPUs as key reasons for recent progress. Question 2. What does object detection do? The correct answer is finds object location and label. Object detection simultaneously identifies where the object is and what the object is. Question 3. Which of the following is mentioned as a field where deep learning is used? The correct answer is natural language processing. The article specifically mentions image recognition, natural language processing, and speech recognition. Object detection is already useful in many practical situations. For example, it can detect and recognize faces, identify pedestrians in traffic scenes, and detect cars for driving and surveillance systems. These are all real-world examples where both location and identity of objects matter a lot. One of the most meaningful applications is in medical imaging. Object detection has shown strong results in developing models that help predict lesions and identify conditions such as liver disease, brain cancer, and fractures. In healthcare, this can support doctors by drawing attention to important patterns in medical scans. The article mentions several imaging modalities used in medical applications. These include radiography, computed tomography or CT, and magnetic resonance imaging or MRI. Deep learning models can analyze these different scan types to detect abnormalities that may be difficult or time-consuming to inspect manually. Now that we've covered applications review, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. Which is an example of object detection in daily life? The correct answer is pedestrian detection. The article lists pedestrian detection as one of the application areas of object detection. Question 2. Which medical condition is mentioned in the article? The correct answer is brain cancer. The article mentions liver disease, brain cancer, and fractures as examples in medical imaging. Question 3. Which imaging modality is included in the article? The correct answer is MRI. MRI is specifically named along with radiography and CT as a medical imaging modality. Deep learning architectures for computer vision are usually built with multiple layers. These layers work step by step, learning from simpler patterns to more complex ones. In image tasks, this layered design helps the model gradually understand edges, shapes, textures, and eventually full objects. Artificial neural networks, or ANNs, are also called connectionism systems. They are inspired by the way the human brain processes information. In these networks, neurons are organized in layers, and each neuron is connected to neurons in the previous layer. This structure allows information to flow and patterns to be learned from data. The efficiency of an artificial neural network depends on three major things mentioned in the article: its architecture, its parameters, and its inputs. In simple words, how the network is designed, how it is tuned, and what data it receives all influence how well it performs on image recognition tasks. Now that we've covered network basics, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Deep learning architectures for computer vision are typically composed of what? The correct answer is multiple layers. The article clearly states that deep learning architectures and networks for computer vision are typically composed of multiple layers. Question 2. What is another name for artificial neural networks in the article? The correct answer is connectionism systems. The article says artificial neural networks are also known as connectionism systems. Question 3. Which factor affects the efficiency of an ANN? The correct answer is architecture. The article says ANN efficiency depends on architecture, parameters, and inputs. That's it for this lesson. If you understood the quizzes well, you've already picked up the core ideas behind deep learning in image recognition. Keep learning, keep observing real-world AI examples, and we'll see you in the next video.